Okay, so now this is a very important slide just to make some observation. Inheritance at the first level, the superficial level, I would say. We'll definitely go into deeper level later. At the superficial level, we can use the inheritance for code reuse to really satisfy the single choice principle by minimizing code duplicates. That's the intention. So inheritance in Java allows you to define common attributes and methods in a separate class. Let's see some detailed list in the case of the student example. Let's say the student class, you define, well, for example, the student class, we put all the common stuff inside, like a register, like a name, courses, array, and also register method, the body of the constructor, and also the base amount calculation for the get tuition method. And you can also define so-called extended version of the class, which will inherit all the definition for all the non-private attributes and methods. That'll be either non-resident students or resident students. It can be name and can be courses and also NOC. So what I meant was, if you go back to this diagram over here, you can see the name, you can see all the attributes, the name, courses, and also number of courses. All these attributes will be made available to the resident students and also non-resident student as if they declare these attributes in their classes, but now they become just implicit. They're simply inherited. And when we visualize the child objects, you will see exactly what I meant. Okay, also register method and base amount calculation of get tuition, right? That's something we just went over already. And this means code reuse and elimination of code duplicates and satisfying the single choice design principle. And in the subclasses, you can also define new attributes and methods if necessary. For example, which I didn't list over here. For example, we got for resident students class, we got a new attribute premium rates and also a new method which you assume set premium rates. Similarly, for the non-resident students class, we got a new attributes discount rate and also mutated method which we assume set discount rate. Okay. They're simply just specific to the kind of students we're talking about. Okay. Okay, set premium rates or for resident students, set discount rate for non-resident students. And you can also redefine or overrides. Remember, we talked about overrides in the context of the equals method. So now we can override any methods that we inherit from our parent classes. For example, let's say for the case of the tuition, right? So think about what's being inherited is this version over here, which will calculate the base amount. And now by redeclaring the method get tuition, for example, in the resident students class, we can first of all invoke the version that's inherited from the parent class, which is a super.getTuition. And then we can just do some the current class specific calculation by applying the premium rates. And similarly for the discount rate. So we don't really have to duplicate the definition for this base amount calculation, which was the problem for version for design number 2, if you recall. Okay, let's now move on. And then also discounted version. Yeah, basically for the resident students get tuition, it's basically apply the premium rates. In the non-resident student class, it applies the discount rate. Okay, let's see how we can visualize the objects of parents and also the child classes. Okay, it's important, but it's actually very intuitive. A child class inherits all the non-private attributes from its parent classes, meaning that as long as the attributes are is either public, which we don't normally do, or it has no modifier, meaning package level visibility, or protected, they will be inherited. So that means a child instance has at least as many attributes as an instance of its parent class. So what do I mean? So you can see this parent class students over here has 3 attributes: name, registered courses, and also number of courses. What about resident students class? How many attributes does it have? Part number 1, it contains all the parent class attributes, all the 3 over here, that are inherited automatically, plus the premium rates over here. So they got 4 attributes. Okay. Similarly, for non-resident students class, how many attributes does it have? 4. The 3 that are inherited from the student's parent class, and also the discount rate that's newly defined in the non-resident student class. This phrase is very, very important. Let me read it to you again. a child instance has at least as many, which means everything the parents has, I have as a child class. But as a child class, I might have even more. That's a very important concept, which we will actually explore further when we talk about expectation on the static types. Just keep that in mind. Okay, let's now consider the following instantiation. Let's say we got student S, also also resident student RS, and also non-resident students NRS. Let's say we got these three attributes. Let's say, and also we're just trying to initialize them accordingly. Let's say we got student Stella, resident student Rachel, and also non-resident students Nancy. So now, how will the initial objects look like? How do we initialize them? It's very important about this diagram here. Let me explain to you. Over here, okay, we got a different kinds of objects over here using the different constructor, right? So you can see for the first objects, we are actually using the constructor from students. Let me say this. Let me use green for a reason. That'll be the parents constructor, and also we also got resident students over here, and also we got non-resident students. Okay, let's see the initialization. Okay, for the student class, for the student object, you can see this is a common attributes that actually are declared in the student parent class, meaning that for the child objects, you definitely contain that part as well. The name, counter, and also the course array. The name, the counter, and the courses array over here. You can think about this part here is more like a whatever that's inherited from super. That's what you can think about. Okay, so these are inherited. Let me just draw a little bit better. This part over here, inherited from the parent class, the parents student class. On the other hand, you can see here we got premium rates over here. That's actually that is newly defined in the resident students class, and also we got discount rate over here that is actually newly introduced by the non-resident student class. So these two attributes over here are specific to the subclasses. Right? So it's really important for you to see the visualization. So whenever you want to visualize an object of the type, for example, resident student or non-resident students of a type that has some corresponding parent class, you must take into consideration the parents declared attributes over here. That's why we got 4 attributes over here, and we got 4 attributes over here. And remember that phrase I want you to remember, right? Let me just revisit that. It's so important. A child instance has as many, at least as many attributes as an instance of its parent class. Now you can see that exactly, right? So you can see subclass over here has as least as many, this part over here. And then you got something extra. Okay, it's a very important point. Let me just emphasize that once more. If you look at this part over here, and also this part over here. Okay, so this part is definitely larger than or equal to. Okay, so what I meant was, well, you're gonna kind of rotate your notes a little bit to see this is really larger than or equal to. Okay. Child instance has at least as many attributes as those of its parents. Counterparts, right? You can see, think about this as a current counterpart. Okay, it's a very important point. That's why I'm keep emphasizing. At least as many attributes. Okay, so that's about visualization. Let's now move on to the next one. Okay, visualization, and let's now see how we can test. Okay, the testing actually, the tester code here is exactly the same as the one for design number 2. Okay, so we don't really have to repeat the visualization. I just want to show you something over here quickly, and then we'll make some remark. Okay, let's take a look. Okay, over here, I just want to show you. So when you actually try to visualize the this particular test case, which is exactly the same as before for version number 2, let me show to you which one I'm talking about very quickly. So for version number for design number 2, remember the test code that's over here. This one here. Oh, that's student management system. So maybe it was for over here. Student tester. Sorry, it took me a little while to actually locate that. So this is the test code for design number 2. And the test code we are seeing right now is exactly identical. Okay. So the point is, we have only modified the internal structure about the architecture, how we split the classes from design number 2 to design number 3. But the way we actually use the classes is still the same. Let's take a look quickly. You can see we're still trying to create, let's say, gym over here being resident students. So gym is resident students. Okay. So here, when I'm trying to visualize, you can think about that's the common part for the that's inherited from the parents. And this part over here is the specific part for resident students. Similarly, you can see non-resident students over here. Let me use maybe pink. Non-resident students Jeremy over here. So that's the objects that we can visualize over here. And similarly, you can see this part here is also inherited from the parents, the common part. But this part over here is the discount rate, which is specific to the non-resident students objects. Okay, and the rest will just be the same. You just set the premium rates, set the discount rate, and you can also aggregate the different courses for registration, and then you can simply calculate the aggregated amounts and then apply the premium rates versus discount rate. That's how you tested it. Okay. And one more thing to mention to you. So this is also some architecture diagram which I'll review. We will need to actually use to do the in-class exercises, the in-lecture exercises. Let me just go over very quickly with you. You can see this part here. The this part here, the name and number of courses, and also the courses array. That's the common attributes which will be inherited. Common attributes which will be inherited to the subclasses, which will be resident students and also non-resident students. So that is why whenever I ask you the question about what attributes do we have for example, resident students, it's going to be the premium rates plus all the common part over here. Similarly, if I ask you the question about what would be the attribute for non-resident students, it's going to be whatever that's newly defined, in this case, discount rates, plus all the common ones, which is over here, right? And also, we got some existing methods that will be inherited from the parent class. For example, the body of the constructor, and also the register method, and also the get tuition, which only calculates the base amount in the parent class. And in this case, when we go to this get tuition, we can definitely actually reuse what we have over here, right? By using the super keyword. That's what we did in the earlier page. And also similarly, when we actually want to redefine or override the get tuition method for the non-resident student class, we can also refer to the get tuition over there by using the super keyword, right? In a similar way. All right, that's the architecture diagram I would like to remind you about, and make sure you're really familiar with it, and we're going to use it to do further exercises later. Okay, the software can be used in exactly the same way as before because we didn't modify the method headers. So all the methods still have the same headers, the same API. It's just that we modify the structure. So now we actually satisfy both the cohesion and also single choice principle. Let me recap, and then we are done with this part. Okay, if you look at the architecture for the code again, we satisfy cohesion because the premium rates and discount rates, they are declared in their corresponding classes without being mixed. So that's how we satisfy cohesion. and also all the common parts of the attributes and methods that can be shared and then inherited to the subclasses that are defined in a single place in the parent class. So that's how we satisfy the single choice principle. For example, let's say now if I want to modify the registration policy, right? In design number 2, we had to modify 2 places because we got two kinds of students. What about now? Well, we only need to modify just a single place for the register method, right? Let me also point it out. It's so important. Okay, so now over here you can see for this one, if the registration policy is to be changed. Okay, maybe make it a little bit thinner. This is the only place. The single place to change. So that's why it actually satisfies the single choice principle over here. It's so important to actually notice that. Single choice principle. Okay, that'll be the only place. The single place to change. All right, so that's about the inheritance solution to actually show to you. Okay, let me see if there's anything else for the slides. Okay, so that's about it. And that's about the 3 designs for the student management system problem, 2 without the use of the inheritance and 1 with the inheritance. Let me just do a quick summary about all the design that I've learned about. Okay, let's now take a look before we go on to the next topic. Okay, let me now summarize very quickly. Okay, so basically we want to summarize about the design versus the principle. Let me now draw a table to actually summarize exactly what we have done so far. Okay, so let's say we got here for the columns is going to be the different design principle that we are trying to compare. One is about whether or not we use inheritance. So is inheritance used? Okay, so that's number 1. And number 2 is the cohesion principle satisfied? Or you can ask about if the design is cohesive. That's equivalence. And then is the single choice principle satisfied? Okay, and for the rows, we're gonna talk about design number 1, design number 2, and also design number 3, right? We follow the order in which we discussed. So design number 1, design number 2, and also design number 3, right? Okay, let's now talk about it, right? Actually, for this, I don't need to really put it into purple. I think blue should be okay. If you don't mind, I'm just being a little bit picky here. Okay. All right, in terms of the use of the design, you can see here, the only one that uses the inheritance was design number 3. So that's why I put green. Green means yes. On the other hand, the first 2 designs, they simply didn't use inheritance, right? What about the design principle? Okay, for design number 1, we actually knew that it actually did not satisfy cohesion because it mixed the premium rate and discount rate into a single class. And also, it did not satisfy the single choice principle because it duplicates the conditional structure for checking the kind of student instances, right? And for the case of design number 2, there's no inheritance. However, we improve about the cohesion by splitting into 2 different classes for the student. However, we duplicated a lot of code, so that's why single choice principle was not actually satisfied. In the case of inheritance, we satisfy cohesion by splitting into 2 classes, and also we use the extends keyword to make sure we can actually put the common parts of the attributes and methods into the parent class students, right? It's a very important summary table to really remind you about the 3 designs that we actually have spoken about. I think up to now, we have done the superficial part, to my point of view, for the inheritance. I spent quite a bit of time really going over in details with you because I think that's really important for you to really understand the rationale about pros and cons for each design that might be possible for your open-ended problem, for the student management system problem. Let me point out one more thing to you on Eclipse. So if you downloaded the source code made available to you, example inheritance projects, if you expand it, you will see 2 packages. So without inheritance, so this is design number 2. For design number 1 that we spoke about, I didn't really have the source code available to you. I would encourage you to really put it into the Eclipse yourself and play with it. Okay, that's some additional exercise I would expect you to do. Okay, without inheritance is basically design number 2, and with inheritance is about the design number 3 that uses the keyword extends and super using the Java inheritance. All right, and that's about the code. You can actually play with them, extend it if you wish, and let's now move on to the next part of the module.